We'll proceed in vector summation and calculus. Vector summation and calculus, in which we have started the discussion. Can we break our problem into part by part, solve it part by part, and then assemble it? Okay, while assembling it, if does not come to accurate, then make it n tends to infinity. What we are saying that if I divide my problem into n different parts and then assemble it and then solution is not perfect, we may make n tends to infinity. Then first we divide the problem into n different parts, solve part by part. By solving part by part, we may need vector. Once we solve part by part and once we assemble all the n units, there are chances that it will not be perfect. To have it perfect, we need it to make n tends to infinity. Okay, when n tends to infinity, the net calculation, what we are doing it, it has to be done through integral calculus. This is what we are saying. Integral calculus is a technology that is made for n tends to infinity. What is integral calculus? Integral calculus is a pure calculation of area. If I am calculating an area, then it is integral calculus. Pure calculation of area is integral calculus. Okay, area can be broken up into n different parts, where n tends to infinity. If I have this x-axis and this is the curve on top of x-axis, that is a circle. Okay, if that is the case, then if this is the curve, let's forget about the bottom part. If this is the curve, if this is fx and this is x, function over x dx will give this area. Or, or if I have small area, this is, I divide this line into n different parts. I divide this line into n different parts. I take any ith part. This part, if I go up, it hits here. If I calculate this area, and if I add all this area, then it becomes full area. What I am trying to say is summation I equal to 1 to n, area of ith section, area of the ith section. If I add all, it becomes fx dx. Okay, what is the area of the ith section? Is fx. Fx means height. Fx into delta x. Fx, x belongs to the ith section. Fx into delta xi. Fx, x belongs to ith section into delta xi. If I multiply this, this becomes the area of this subsection. If I add all area, all subsection area, then it becomes full fx dx. Fx delta xi summation I equal to 1 to n tends to infinity, means the delta x tends to 0. Why delta x tends to 0? Because bottom of this sub area is flat, that is alright, but top part of this area is also flat if I say fx into delta x, but we want it to be curved. To have the curve and flat lines similar, I have to make the delta x tends to 0. But as I have always said, this is not the actual integration. This is what generally people take it. What people do is summation sigma I sigma, that is summation I equal to 1 to n tends to infinity. Function over x belongs to ith section into delta xi. This is the basic, basic representation or basic nomenclature of integration. That is not true. Integration can be broken into this. That is fx dx. F, if this equation is fx into dx, and then from here x from where to where? From here to here. Then full area it will be. Forget the bottom part. Below x-axis, just forget it. From minus a to a, if this is a circle, it will give this area. Fx dx. Okay, that is the concept. Simple. If I have fx, that is the height, and if I multiply with the x, that is width, that is dx, it will give the area underneath. This is typically called pseudocode. We will use pseudocode. What is the pseudocode for integral calculus? Pseudocode for integral calculus is calculating multiplication through area. That's what is area? Area is height by width for any shape. Yes, any shape. If it is rectangle, then height by width is physical area. If I say fx into dx, it is a physical area as far as rectangle is concerned. What about non-rectangular case? Still height by width is the area. Fx into dx is the area. For rectangle, it is fx into x is the area. Okay, for others, we say fx into x is the area, but that is a pseudo code. For circle also, the height, if I take half of the circle, then height into width is the area. Fx into x is the area. But it is abstract code. This is not in the reality because height is changing as per the x. It is not constant like rectangle. So x, I denote it dx. Fx into dx is the area. So that people will understand this is a pseudo code. This is not the actual code. Otherwise, people will say fx into x. X fx is the area. What is fx? Fx is sin x. Sin x. Sin goes like this. Sin x. Sin x into x is the area, but that is not. Sin x dx is the area. What is dx? Dx, d is placed there to separate it from normal multiplication. Normal multiplication will give the area if it is a rectangle. If it is a rectangle, the normal multiplication of height, that is constant everywhere, into x will give the area. If it is not a rectangle, then still height by width will give the area, but that is a pseudo code. So to represent pseudo code fx into x, we change x into dx, fx into dx. If someone sees it fx into dx, he understands it is a pseudo code. If fx is rectangle, then silently he can remove the d, not required, not required. Fx into x, what do you mean? Height is constant. Height is constant. What is constant? Y. Y is the height. What is base? X. Y into x is the area. But if height is not constant, y is not constant. It varies with the different x. Then y into x will not be the area. Y into dx will the area. D will place there to confirm it is a pseudo code. It is not the perfect multiplication. That is right. Anyway, we are in phase of calculating the circumference of a circle. Circumference of a circle, where circle may be centered at the origin, may not be centered at the origin. If this is a circle, if this is the circle, circle may be centered. This is the circle centered at the origin. What is the equation of the circle that is centered at the origin? X square plus y square equal to a square. A is radius. X square plus y square equal to a square. Is it the actual representation of circle? No. It is actually x minus 0 whole square plus y minus 0 whole square equal to a square. That is the equation of the circle. What is 0, 0? 0 means circle is centered at what? If circle is centered at 0, comma 0, then it is x minus 0 whole square plus y minus 0 whole square equal to a square. What about circle is centered at any arbitrary point x1, y1? Means if this is the origin, then circle is not here. Circle is centered at any point here, whose center is x1, y1. The center is x1, y1. Means this is x1 and this is y1. This is x1, y1. Circle is centered at x1, y1. Circle is centered at x1, y1, where x1, y1 is 0, comma 0. In Python, it is a tuple 0, comma 0. What about this? Circle is centered at x1, comma 0. What about this? Circle is centered at 0, comma y1. What about this? Circle is centered at any point x1, y1. If it is centered at x1, y1, then circle equation is x minus x1 whole square plus y minus y1 whole square equal to a square. I believe this is all right. Okay, it will be like that. Okay, now I have taken in previous video, in the previous example. We tried calculating the circumference of the circle when circle is centered at the origin. We were trying to verify that, like, if I say that I have a Cartesian coordinate system, then any point in Cartesian coordinate system I can take x comma y. If I have a polar coordinate system separately, then any point in polar coordinate system I can take this as theta and this is r, any point as theta comma r. But if I have a Cartesian coordinate system where this is x-axis and this is y-axis, I can take any point as x comma y. Okay, if I mix polar coordinate system inside Cartesian coordinate system, okay, what is polar coordinate system inside the Cartesian coordinate system is is if this is x and this is y, then there will, this is origin. Let's connect this origin and a point here called x comma y through a line. Okay, like that. And this line is start keeping this end of this line as fixed. It is not changing. Always sticking to this point. I have stitched it. Okay, I have nailed it here. And then this point is varying. If this point vary like this in xy plane, it varies like this. It makes a line. Okay, this line which varies keeping one point constant at origin and other point is varying like this. This is typically called radius. And when it is varying, it is making angle with the x-axis. This is called theta. This is another coordinate system inside xy plane. This is x, this is y. Inside xy plane, I can have another coordinate system called superimposed coordinate system, where this is radius and this is angle. For to have a coordinate system, both should be perpendicular to each other. Like if I say this is theta and this is r, then theta and r are perpendicular to each other. If I say this is x and this is y, then x and y are perpendicular to each other. R theta must be perpendicular to each other. If this is radius, then theta is like this. How they are perpendicular to each other? To represent theta, like if I take any point here, then this is x comma y. Same point if I take in polar coordinate system, it will be r comma theta. R is radius, that is distance, and theta is angle. If theta is angle, r is distance, and theta is angle, then both are different. They both should be same. So if I move this angle theta, then there is an arc that is moving like this. So this point will be r comma r theta because arc length is r comma theta. This point is r comma r theta. If I talk about this vector that is this vector, if I talk about this vector, then it has two components. The position vector of this vector, it has two components. If I talk about x comma y, then vector, then it will start from the origin, and then vector will be xi plus yj. If I talk about the vector here, then it will be r unit vector, that is along this direction, and another is plus r theta is vector. This is r theta, where r is constant. If I say r theta, then r is constant. R is not variable. If r is not variable multiplied by the theta that is variable, it will make a like this. It will make a curve like this. Means that will go exactly tangent to what I am trying to say is, if I have a circle like this, these these are very minute thing. If someone understand it very clearly, he can crack any example. Because if someone sees any mechanical engineering example, electrical engineering example, electronics engineering example, transistor characteristic, diode characteristic, they are in exponential, logarithmic, sinusoidal, whatsoever. Okay, at the end, they will come in this miniature science only, position vector, tangent vector, and these vectors only. So if I have a circle that is centered at the origin, if I have a if I have a circle that is centered at the origin, then if this is the radius is moving along this curve. If I have any point here, that point will be radius r, and this r theta, r comma r theta. Okay, the vector representation will be r unit vector plus r theta unit vector. Okay, anyway, we are calculating the circumference of the circle. What is circumference of the circle? Now we if I talk about the r and theta, then one r and theta, then this is xy plane, this is theta r plane, this is xy plane, this is theta r plane. Okay, in xy plane we have a circle. Okay, accordingly in theta r plane there will be a rectangle. Okay, how it will be rectangle? Because what is equation of circle if I talk in polar coordinate system inside the xy coordinate system? Then it will be r equal to a. Radius is always a. That is the formula. Radius is always a. That is the formula of circle in polar coordinate system. R equal to a. If I say r equal to a in polar coordinate system where this is theta and this is r, a is this height and it will always be a. There will be a parallel line, there will be a flat line with height is a. It will pass like this. If I say theta is 0 to 2 pi, then it makes a rectangle. And here in xy plane, it will form a circle centered at the origin. If circle is not centered at the origin, this is the circle. Consider this is the circle in xy plane. What is the equation of the circle? It is centered at a point called 0, comma 1 by 2 for simplicity. 0, comma 1 by 2. It is centered here. What is the equation of the circle? X minus 0 whole square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. That will be equation of the circle. What is relationship between x and y? What is relationship between x and y? If I take what is the radius of the circle? Okay, what is the radius of the circle? If I take the circle, what is the radius of the circle? Center is here. The center of the circle is here. This is y-axis. This is y-axis and this is x-axis. This is center of the circle. If this is the center of the circle, then there is a radius. Radius must connect one point to the center of the circle. I'm sorry. This is origin 0, comma 0. Center of circle is here. Okay, this is a shifted circle. Otherwise, circle would have been here, centered at the origin. Now I shifted the circle up. Now this is a new circle where this is x-axis and this is y-axis. This point is 0, comma 1 by 2. What is radius? Radius, one end of the radius must be connected to the origin. Radius is moving like this. Radius is changing its length. When angle is 0, radius is 0. When angle is growing, when angle is 90 degree, radius is full. When angle is growing, radius is decreasing. Okay, what is equation of this circle in terms of polar coordinate system? Substitute it. Earlier we had x square plus y square equal to a square. That was the equation of the circle centered at the origin. Now x equal to r cos theta and y equal to r sin theta. Okay, or if someone has other doubt, then we can say x square plus y square equal to radius of the circle, where radius is fixed. Radius is fixed. Okay, means every point on the circumference x, if this is x comma y, x square plus y square is a fixed amount. What is x square plus y square? If I take this point and that is a fixed amount, means when circle is centered at the origin, then only it will be fixed amount. Otherwise, it won't be a fixed amount. And anyway, when circle is centered at the origin, when circle is centered at the origin, when circle is centered at the origin, when circle is centered, when circle is centered at the origin, when circle is centered at the origin, this point is x comma y. If this point is x comma y, then this everywhere, if this point is x comma y, this point is x comma y, this point is, they have a relationship. X square plus y square equal to a square. A is the radius. Always fixed. It is fixed. Means this radius is x square plus y square. That is fixed. Okay, what about this angle? Then it is y by x, means theta equal to tan theta equal to y by x, where r square equal to x square plus y square. If I break it, it becomes x equal to r cos theta. and y equal to r sine theta. Okay, if I'm talking about a circle that has a center at in y-axis and end of the circle is at the origin. If this is the circle, oh, oh, oh. If this is a circle whose one point is origin and one circle end point is origin and circle is centered at 0 comma 1 by 2, this is the radius. Okay, now let's find the equation of this circle is r theta. X square plus y x square or x minus 0 whole square because center is 0 comma 1 by 2. X minus 0 whole square plus y minus 1 by 2 whole square equal to is equal to 1 by 2 whole square. 1 by 2 whole square is a radius. If someone set x equal to r cos theta and y equal to r sin theta here, he will get r equal to sin theta. This is the equation of circle in polar coordinate system inside xy plane. R equal to r equal to sin theta. If I draw r equal to sin theta in theta r plane, if this is theta and this is r equal to sin theta will draw like this. R equal to sin theta will draw. If r equal to sin theta is a wave in theta r plane, then accordingly in xy plane it will be a circle. It will be a circle which is centered at 0 comma 1 by 2. One end is touching the origin. In that manner, means we can have different circle x minus 1 by 2 whole square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. Set x equal to r cos theta, y equal to r sin theta. And then now the equation is only in r and theta. Settle it down, bring it to the minimum complexity and see what is the relationship between theta and r. In theta and r plane, they will look like that. They will look like that. If it is x square plus y square equal to a square or 1 by 2 whole square, x equal to r cos theta, y equal to r sin theta, then it will become r square equal to 1 by 2 whole square, r square equal to 1 by 2, that is the radius. Fix. R is not dependent upon theta. These are the small things that person should understand. Anyway, now we are trying to calculate. First, we calculated the circumference of a circle when circle is centered at the origin. If circle is centered at the origin, then calculating the circumference of the circle, means radius will not change. Radius is fixed. If radius is fixed, now we will cut our circumference into n different parts, or the angle or the radius that is moving in the angle. This radius is moving where angle is changing, radius is not changing. This angle is going from 0 to 2 pi. If I cut this angle into n different parts, then we have different section along the arc. Let's take any ith section. Okay, if I cut this angle that is going from 0 to 2 pi into n different parts, this is the first part. This is the second part. I'm sorry. This is the first part. This is second part. This is third part. Consider there is any ith part like this. If there is an ith part where radius is constant, this radius and this radius, they are of same length. Then what is the length of this vector? Length of the circumference. Consider the length of the circumference is L. Then summation I equal to 1 to n length of the ith section will give the full circumference length. Okay, but we don't know what is the length of. If I know what is the length of this section, then I would have gone for the full circle. Why I need to break into n different parts? I don't know. The reason to breaking into n different parts because we don't know the exact curve length of the circle. I know straight line length. Consider this point is x1, y1. This point is x2, y2. In that fashion, this length vector, consider this point is P. This point is P1 and this point is P2. This is x1, y1, this is x2, y2. What is this vector connecting origin and x1, y1? x1i plus y1j. What about this? x2i plus y2j. Okay. Then what is the line that connects x1 y1 to x2 y2? This line that connects x1 y1 to x2 y2, that line is x2 minus x1 I plus y2 minus y1 j. A line connecting x1 y1 to x2 y2, what is the vector representation of that line? Then it is x2, it is x2 minus x1 I plus y2 minus y1 j. Okay, that is same as x2i plus y2j minus x1i plus y1j in bracket. That is same as p2 vector. x2i plus y2j is p2 vector. This is p1 vector. Then it will be p. This is p2 vector. This is p1 vector. P2 minus P1 is actually this. That is x2 minus x1i plus y2 minus. Means if I say this is P2 vector and this is P1 vector, then I have this vector. If I say the same thing what we are writing here, what is the circumference of the circle? Summation I equal to 1 to n, length of the ith section, length of this arc of the ith section. That I don't know. Okay, but more or less similar in similar fashion, I can say length of the ith section is nothing but P2 minus P1 magnitude. If this is P2 vector, this is P1 vector. If I subtract it, then it will become P2 minus P1 vector. If this is the vector, P2 minus P1, if I calculate this magnitude, it will give the length of this. Means P2 minus P1 magnitude of the ith section, summation I equal to 1 to n will give this length. P2 minus P1 I can represent as delta P, delta Pi, delta Pi. Okay, what about if I divide this? Okay, what about, so now summation I equal to 1 to n magnitude delta Pi. Delta Pi is this new vector P2 minus P1. Okay, delta Pi. Now delta Pi, if I have delta Pi, okay, then but delta Pi, how I can calculate delta Pi for the ith section? There is nothing x1 y1 or x2 y2. I have to come to generic algebra only. Otherwise, how we calculate? If I divide into n different parts, how I know x1 y1 and x2 y2? Okay, but still it is not perfect, because that is a straight line. If I add all the straight line, it will not be perfect circumference. I have to add all the curved line, then only it will be circumference. For that n tends to infinity, I have to make n tends, because I have to cut now this angle 0 to 2 pi into n part, where n tends to infinity. Very minutely I have to cut. Then only I'll get a similar result. Otherwise, this is not a perfect result. Means it is impossible that when someone dividing into n part, 10,000 part, 1 lakh part, 100,000 part, then every x1, y1 someone will calculate and then vector subtract it and calculate the magnitude and say summation I equal to 1 to n delta Pi will be the length of the is. Then it is impossible. No one can do it. I have to bring into the variable algebraic form. So if I say delta Pi, I can write delta Pi as delta Pi by delta Xi into delta Xi. Who is stopping us? I can divide by something by same thing and multiply by same thing. It will be same thing. What is the length of the circumference? Summation I equal to 1 to n. Magnitude of delta Pi, delta P2 minus P1, its magnitude for the ith section. Delta Pi magnitude, so I am writing summation, that is sigma sign, summation I equal to 1 to n, and then in magnitude delta P ith section. Okay, if that is the case, then I can rewrite as delta P of the ith section by delta X into delta X. I can take out one delta X from this magnitude sign. Now delta P by delta Pi by delta X magnitude into delta Xi. Someone can say that magnitude also, no problem. But right now it is like that. Delta Pi by delta Xi magnitude into delta Xi magnitude, whatever. Okay, if I say delta Xi tends to 0, what is delta X? If I have like this, then this from here to here, this is delta X. From here to here, this is delta Y. for the ith section. If I say delta pi by delta x, anything by delta x where delta x tends to 0, it is same as dp by dx. So I can rewrite as dp by dx magnitude delta xi magnitude, but delta xi is the ith section xi. dp by dx will be a function over x. Function over x into delta xi summation I equal to 1 to n, where n tends to infinity. It is a typical case of bringing it to integral calculus. Function over x dx and integration of it from lower limit to higher limit for what we wanted. Okay, we have seen it. We now, if I say dp by dx, p is position vector. Position vector can be x1, y1. Position vector can be r comma r theta also. P is P. P means position vector. Position vector can be anything. Position vector can be in Cartesian coordinate system x comma y. Position vector can be in the polar coordinate system of r comma r theta. Okay, divide by dx. Okay, P can be anything. We have taken it. Let's say P is x comma y. Then it becomes dp by dx. P is xi plus yj, its magnitude. I plus dy by dxj, its magnitude dx. 1 plus dy by dx whole square root dx. Y equal to square root of a square minus x square for the circle. It will become 1 plus x square by a square minus x square square root. It will become a by square root of a square minus x square dx. This is the from x that spans. This is when circle is centered at the origin, where x spans minus a to a. Okay, x minus a to a, and then a by a square root of a square minus x square dx. It will give, since we have taken everything in x axis, then it will give the top circumference, not the bottom, because x minus a. What is full? Full is x equal to a back to a, x a back to a, and then a by a square root of a square minus x square dx will give the full circumference. Minus a to a will give the half of it. Okay, a I can keep outside. 1 by a square root of a square minus x square is sine inverse x by a. Okay, sine inverse 1 minus sine inverse minus 1. Pi by 2 plus pi by 2. Pi by 2 a. Pi by 2 pi a. 2 pi a is the circumference. Okay, what if I take P as polar coordinate system? dp by dx. P is r unit vector plus r theta unit vector by dx. Then it will become dr by dx r unit vector plus dr theta by dx theta unit vector into dx. What is dr by dx? How much radius is changing? How much radius is changing with respect to x? Okay, radius is x square plus y square square root whatsoever. Square root of x square plus y square, it looks variable, but actually it is constant. It never changes. Then dr by dx, r where it never changes with anything, dr by dx is 0. D of r theta by dx will be r d theta by dx plus theta dr by dx in loose term. Okay, dr by d theta is 0 also. Then it will become d r d theta by dx, r d theta by dx, theta unit vector. If I square it and take a square root, what I mean is dp by dx magnitude dx, x from minus a to a will give the half circumference. This is what we are saying. Okay, if we are saying in that fashion, p I can take in polar coordinate system. R unit vector plus r theta unit vector, because r and r theta are the two coordinate we have taken. Because r and theta, that is the circumference, they are perpendicular to each other. It makes a coordinate system. Okay, when p is in r theta and differentiation is with x, will it work? We will try. Dr by dx, which is 0. D theta r by dx, that will become r d theta by dx. Okay, now its magnitude will be same, r d theta by dx, or otherwise it would have been dr by dx whole square. plus d of r theta. Here r is constant. I can take out r. D theta by dx whole square. Okay, square root dx. Anyway, dr by dx is 0. D theta by dx r. If I take whole square and then square root, it will become r d theta by dx dx. What is d theta by dx? Theta equal to tan inverse y by x. Then d theta by dx will be 1 by 1 plus tan inverse x. Differentiation is 1 by 1 plus x square. D theta by dx, d theta by d of tan inverse y by x by dx will be 1 by 1 plus y by x whole square into differentiation of y by x, that will be y minus 1 by x square. Okay, it will become like x square by x square plus y square into minus y by x square. It will become minus y by x square plus y square. Minus y by x square plus y square. This is how it will be. That will be r square, and r is there, a is there. It will become minus y by a. It will become minus y by a. Okay, someone can say minus y by a is constant. You can keep outside. Y dx is the area. Okay, y dx is the area. I don't know what is y dx is the area. What is y here? The square root of a square minus x square. Outside I have kept 1 by a. Okay, square root of a square minus x square dx should give the area as per the polar coordinate system. Someone can try. What is the square root of a square minus x square dx? Okay, if I go by the by normal integration, then the square root of a square minus x square is x into square root of a square minus x square by 2 plus a square by 2 sine in a square by 2 sine inverse x by a. This is what I have seen. Okay, if someone is taking x minus a to a, first will go away. X into a square root of a square minus x square, it will go away. Second is a square by 2 sine inverse x by a. Then it will come as a square by 2. I can keep outside. 1 by a is already outside. It will become a by 2, that is outside. Sine inverse, then it will be pi by 2 plus pi by 2. It will be pi by 2, pi by 2 plus pi by 2. Okay, then how pi a by 2. This is the area whatsoever. This is how it is. Okay, is it really all right that we have done y dx as a circumference? Okay, someone can think, but this is how it is coming through polar coordinate system. Can we use this to calculate polar coordinate system? Means dp by dx magnitude into dx, dp by dx is magnitude into dx, to calculate the area of a circle. To calculate the area of a circle, that circle is not centered at the origin. This is the circle. That is r equal to sine theta. That is the equation of circle. R equal to sine theta, or x square plus y minus 1 by 2 whole square equal to 1 square, 1 by 2 whole square. This is the center of the circle, 0 comma 1 by 2. If this is 0 comma 1 by 2, this is origin. Origin 0 comma 1 by 2. Equation of the circle is x minus 0 whole square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. Someone can keep it here. dp by dx magnitude dx, x from x, no x, where from x is going. X, if I see the x, if I see the x is still going from minus a to a. Okay, if you see the circle, this is minus 1 by 2. This is plus 1 by 2. Y is 1 by 2, 1 by 2, but x will go like this. Someone can try dp by dx, where p is xi plus yj. Then it will be 1 plus dy by dx, whole 1 square plus dy by dx. X dp by dx, p is xi plus yj. That will be I plus dy by dx j magnitude, 1 plus dy by dx whole square root dx. What is y? What is y? Y equal to y minus 1 by 2 whole square plus x square equal to 1 by 2 whole square. Y minus 1 by 2 whole square equal to 1 by 2 whole square minus x square. Then y minus 1 by 2 equal to square root of x square root of 1 by 2 whole square minus x square. Y equal to 1 by 2 plus 1 by 2 plus square root of 1 by 2 whole square minus x square. Now someone has to do dy by dx on top of it. If someone does dy by dx, 1 by 2 will go away. It will come to the same situation what we had done. So the circumference is not different. If you keep changing circle from here to here, whatsoever, it will come to same equation, that is a by square root of a square minus x square. Same. Okay, where circumference will be same. Let's try with the dr by dx, where r is r unit vector plus r theta unit vector. If I do by dx, it will become dr by dx. dr by dx means if this is the radius, if this is the center, if this is the origin, and this is the circle, then radius is changing like this. If I vary along x-axis, then radius length will change. If x is 0, then radius is maximum. When x is 1 by 2, then radius is here. When x is back to 0, then radius is 0. When radius grows with the x, then it starts shrinking. Then radius becomes, then when x is 0, then radius is maximum. Means when x is growing, radius is growing. After that, when x starts decreasing, the radius keeps growing. Similar fashion, it happens like this. This is like that. Now, dr by dx is not 0, that is for sure. What is dr by dx? Now, what is r? R equal to sine theta, that we have seen. X square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. So someone can keep x equal to r cos theta, because if even though circle origin is here and this is the circle, then if I talk about x, if I talk about any point here, x comma y, if this is the radius, momentarily the radius is changing. Momentarily, if this is radius r, then x equal to r cos theta, and y equal to r sin theta. Then I can keep it here. X square means r cos theta whole square plus y minus 1 by 2 whole square, y equal to r sin theta minus 1 by 2 whole square equal to 1 by 2 whole square. It will come as r equal to sin theta. That is the equation of circle. If I say dr by dx, okay, I plus dr theta by dx, j, its magnitude d theta dx. Now it is, if someone is very good in mathematics, then he can try. What will be its magnitude? Dr by d theta whole square, dr by dx whole square plus dr theta by dx whole square, square root into dx. Okay, what is dr by dx? What is dr by dx, where r is changing with the x? Okay, r equal to r. Here r, if I talk about the radius, r equal to x square plus y square. That is not constant. It keeps changing. X square plus y square is not constant. X equal to r cos theta, y equal to r sin theta. Okay, r is variable whatsoever. If I do x square plus y square, it will become r square. dr by dx, if I say, then r is the square root of x square plus y square, which is not a constant now. Then d of a square root of x square plus y square by dx whole square plus d of r theta, In this calculation, we consider r as constant. Now, someone can proceed with the both scenario. If r is not constant, then d of, in bracket, r is the square root of x square plus y square, theta is tan inverse y by x by dx whole square root into dx. Someone can try. No one is stopped. We will take easier path, but someone can go. Someone who is mightiest, very powerful, he can try. Keeping r as constant in r theta and keeping r not as constant in r theta, and then try dr by dx whole square plus d of r theta by dx whole square root into dx. What solution comes in? Anyway, we will take shortcut path and dr by dx is same as dr by d theta into d theta by dx. Okay, d theta r by d theta r by dx is same as d theta r by d theta into d theta by dx. D theta by dx will come out. Now dr by d theta whole square plus dr theta by d theta whole square root. This is 1 that is already calculated. This is certainly 1. Dr by d theta, if I say that if r equal to sine theta, then dr by d theta is cos square theta. Dr theta by d theta, where r is constant, r d theta by d theta, r square. One is sine square, one is cos square, square root 1. This will come as 1. Now the net solution comes in d theta by dx into dx. What is d theta by dx? Tan inverse y by x by dx. That will come as minus y by x square plus y square dx. Someone can try. Minus y by square minus y by x square plus y square dx, x minus a to a. Will it give the circumference of a circle which is not centered at the origin, or of a circle where r is function over theta? Okay, someone can try what it will come. Okay, I believe the integration of 1 by x square plus y square is 1 by y, and then 1 by y tan inverse x by y. This is what I think. Okay, so if it is minus y by a square plus y square, minus y will come out. 1 by a square root of a square plus y square square root. That will come as 1 by y. So y will go away, I think so. And then it will be tan inverse x by a. X is minus tan inverse 1. Minus tan inverse minus 1. Something like that it will come out. Pi by 4 or pi by 4. It will come in pi and something. That will be circumference. It will not come as pi, okay, pi into something. Hope. Someone can try. Okay, this is the way we can calculate the circumference. Circumference, I'm not sure about if it is y by x square plus y square. Y I can keep outside. 1 by x square plus y square. The integration of this. I think so it is. It comes as 1 by a. It comes as 1 by a or 1 by a square. I'm not sure about it. 1 by a and then tan inverse something like that. Someone can try how it comes. But this is how we can calculate in hybrid model parameterization dr by dx into dx to calculate the circumference of any circle in the hybrid model. Means in the polar coordinate system inside xy plane. Someone can try more on it. It should give the perfect result. I think so. Okay, someone can try completing it. Whatever we talk here, all are research based. There is nothing like we have read from any book. Please do not mind supporting us. Plus 91 is the India country code 9483160610 is the telephone. Plus 91 is the India country code 9483160610 is the telephone.